Hello everybody, welcome to Max Tutorials. This is version C of solving equations with fractions and decimals. If you've gone and already seen version A and B, I hope you did, and that should really help you explain this. And as a reminder, you can always go to maxtutorials.com to find more problems like these, where I have a whole sequence of algebra where you guys can get all the help you need. Okay, please like and subscribe, it'll really help me out. So what we're explaining in the other versions is when you have a fraction, you want to multiply everybody by what we call the least common multiple, which is the smallest number that both denominators will go into. Well, on this one, it'll be 4. It's like 4 over 1. Because watch, 2 goes into 2 once, 2 goes into 4 twice. I'm going to multiply that by x, and I get a 2x. Equals, now let's pretend I didn't do anything. You can use an eraser or whatever. 4 goes into 4 once, 4 goes into 4 once. 1 times 9 is 9. That's all it is. Now, I know some people know how to do proportion problems, and you have a better way to do it, which is fine, but this way works, and that's what I want to teach people for the moment. Okay, so number 2, when you see a decimal, you can always move all the decimals the same amount of spots. So here, I want to move him once and him once. I'm totally allowed to do that. Why am I allowed to do that? Well, the answer is what I'm really doing is I'm multiplying each side by 10. Every time you move a decimal spot, you're multiplying by 10. Twice, 100, 3, 1,000, 4, 10,000, etc. So you're allowed to multiply everybody by the same, so you're always allowed to move the same number of decimals. Now, as I solve this, you're usually going to get kind of a nasty number that you don't really like using, but that's okay. Will 12 go into 84? Honestly, on the surface, it will. Okay, but let's say you don't see that right away. What number do you know will go into 84 and 12? Well, maybe, I hope you see 4, because 4 will go into 8 twice, and 4 will go into 4 once, and 4 will go into 12 3 times. And now when I get there, I'm left with a 7. Okay? Now, let's go on to number 3. All right, now that's like a 1 on the bottom, right? So now the denominators aren't the same, but I got to multiply by something. And in this case, I'm going to multiply everybody by a 3. Okay, well, what's 3 times x? 3x, pretty simple. But now what's this other one? These 3 cancel out, and I'm left with a 7. These 3's cancel out, and I'm left with just a 19. Now you guys probably feel a lot more comfortable solving this one than the other one, right? Subtract 7 from both sides, and I'm going to get 3x equals 12. Divide each side by 3, and I get a nice, easy x equals 4. Okay? Let's go on to number 4. All right, decimal ones. Now, these ones aren't the same. Now, remember, if I move these over, I'm allowed to because I multiplied by 10. I multiplied by 10. No decimal. What am I going to do? Well, I'm going to take that 1 and I'm going to multiply him by 10. And I'm going to get 10x equals 2.7. Oh, not 2.7 anymore. I moved them. 27 equals 53. You can also think it like this. That's a 1.0x, right? And I moved them over once and got it to the 10. All right, so now I'm just going to get letters on one side, numbers on the other by adding the 27 to both sides. Boom, die, and I get 10x equals 80. And then once I divide each side by 10, I get a nice, pretty 8. If I went too fast for you on that, where'd it go? Then just go to maxtutorials.com. That ended up just being a 2-step equation, and I have a whole video on 2-step equations. I'm making the assumption that you already know how to do those because you got to this step. But if not, that's okay. Just go back. Now, I've got denominators that are all different. What am I going to do? I'm going to multiply by the least common multiple. Start with the biggest number, 4, and ask if the other 2 will go in the 4, and they will. So I'm going to multiply everybody by 4. These 4's cancel out, and I'm left with 1 times x is x. Okay, let me erase that. Now, plus, now I'm going to go to the next term. 2 goes into 2 once, 2 goes into 4 twice. 2 times 3 is a 6. Now I'm going to do the third one. Boom, 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 boom. 2 times 11 is 22. Now I just have a 1-step problem. Going to subtract 6 to both sides. X equals 16. And that was probably easier than you trying to work out common denominators and do all that. Number 6. They're all 1 decimal past, aren't they? That's fine. 3x minus 21 equals 39. Now, all I'm going to do is treat this like a two-step problem. That's going to equal 60, and then once I divide by 3, I have a very simple x equals 20. Okay? Cool. Let's go on to number 7. Well, they're all one decimal past. Am I allowed to do that? Yeah. All I did was divide by, sorry, not divide. All I did was multiply by 10. Okay? Now I get this. Now I'm going to subtract 12 from both sides. Boom, die. 24x equals, what is that? Well, 8 minus 2 is 6. 10 minus 1 is a 9. And now the question is, will 24 go into 96? And the answer is, well, I'm looking at that. Okay, so I'm looking at, well, I believe it'll be 4, but I'm not 100% sure. So let's give it a try. Well, let's see what numbers will go in. I can tell that 3 will go in the 96. That's easy for me to see because 3 goes in the 9 3 times, 3 goes in the 6 twice. I can see here 3 goes into 24 8 times. Oh, I love 32 divided by 8. That's just a very simple 4. Okay, that's all you get. Let's go over here to number 8. Different denominators. Multiply by the least common multiple. Start with the bigger number, 6. Will 3 go in the 6? It will, so that's what I'm going to use. These 6's cancel out, and I'm left with just a 1 left over, so that means the first term is just an x. Second term, 3 goes in the 3 once, 3 goes in the 6 twice. 2 times 5 is 10. Last one, 3 goes in the 3 once, 3 goes in the 6 twice. 2 times 7 is 14. Now, that looks like a problem that's a lot more fun to solve, doesn't it? Okay, so whenever you get these, if they throw little challenge problems with you, there is a way to solve them. Okay, let's go back over here to number 9. I see that they are all one decimal path, so I'm going to multiply everybody by 10, which will give me a 15x plus 25 equals a 5x plus 75. All right, I got variables on the left and the right. So I'm going to move the variable in such a way to keep the variables positive. You don't have to, but it's my suggestion. You'll usually make less mistakes that way. And now when I see this, I'm going to go, oh, that was really ugly, wasn't it? 10x plus, okay? Now I'm going to subtract 25 from both sides, and I'm going to get 10x equals 50. And when it's all said and done, my answer is a nice, pretty, uh-oh, where'd my pen go? I lost my pen. Did my pen run out of juice? I'm sorry if it did. Or did I just lose connection? I'm going to get an x equals, I just lost connection. Whoops, sorry about that. Maybe I'll edit that out. Or maybe I'll just keep it so you can see that life doesn't work easy all the time. I'm just ignoring this 10. Please try to ignore that with me. I need a least common multiple. Start with the biggest, which is 6. Will everybody go in the 6? Yeah, they will. So I get a 6 over 1. Okay, let's start with the very first term. 3 goes in the 3 once, 3 goes in the 6 twice. Times that by x, and I get 2x plus. All right, let me just erase all this. Okay, now I'm going to go this term. 2 goes in the 2 once, 2 goes in the 6 3 times. 3 times 1 is 3. Okay, now let's do the third term. There's got to be a better way for me to erase, right? There we go. All right, so here we go. 6 goes in the 6 once, 6 goes in the 6 once. That's just going to become an x. And finally, I'm losing connection again. I must be low on batteries. I apologize for that, my friends. Oh, get me through this video. Please just get me through this video. And so right here, I'm going to go 2 goes in there once, 2 goes in the 6 3 times. 3 times 5 is 15. Now I've got variables on both sides, so I'm going to subtract each side by x. I'm going to get x plus 3 equals 15. Now I'm just going to subtract 3 from both sides, and I get x equals 12. All right, let's see if I can get through these 4 before I need to recharge my pen. Okay, let's move on to number 11. When I see the decimals and distributive property, it's just easier if you can just deal with multiplying. I know the adding and subtracting gets a little bit weird, but 3 times 0.4 is 1.2x. and 3 times 1.5 is 4.5, okay? And that equals 6. So again, multiplying with decimals are a little bit easier. Hopefully that works for you, okay? Now what I'm going to do is I'm going to add 4.5 to both sides. Actually, I'm not going to do that yet. I'm going to do my little decimal thing. Sorry about that. I'm going to move everybody over one spot, which would mean I get 12x minus 45 equals 60. I'm going to add now 45 to both sides. Boom, die. And I get 12x equals 105. Now, if I divide each side by 12, it's not going to come out evenly. It's going to be 8 point something. So let's just kind of figure this out. Let's see what numbers will go in. Now, watch this. I know 3 will go into 12. Will 3 go into 105? Not really sure, but watch this. 1 plus 0 plus 5 is 6. If you add the 3 digits and you get a number divisible by 3, it means 105 will divide by 3. Watch this. The bottom's going to be 4, right? I'm going to go 3 into 12 and I get 4. Now watch this. How many times will 3 go into 10? 3 times. With how many left over? 1. I write it there. How many times will 3 go into 15? 3 will go into 15. 5 times, my answer is 35 over 4. If your teacher really wants a decimal answer, well, that's okay. Let's go ahead and do it. 4 will go into 35 how many times? 8. Ooh, look at that number. But with how many left over? 8 times 4 is 32, so I'll have 3 left over, 3/4. And you should know, without having to do any math, that 3/4 is 0.75. So it's 8.75 when you get done with it. Okay? Let's go on to number 12. So first thing I'm going to do is I'm just going to multiply, because multiplying with fractions isn't hard. You just multiply numerator and denominator. 2x over 5 equals 6 over 2. You just multiply the numerators. You don't have to worry about, oh, sorry, it's not an equal sign, that's a plus sign, huh? You don't have to worry about common denominators when you're multiplying. So now I look for the least common multiple. So now right here, I got to multiply everybody by something. Well, I take 5. That's my biggest number. That's my biggest number right here. Will 2 go in the 5? No. Go up another multiple, 10. Will 2 go in the 10? Sure will. So I'm going to multiply everybody by 10. Once I do that, here's what I'm going to get. I'm going to write it to the right because I wrote kind of big here. So I'm going to write it over here. I'm going to go 5 goes in the 5 once, 5 goes in the 10 twice. 2 times 2x is 4x plus. Now I'm going to do this term. 2 goes in the 2 once, 2 goes in the 10 5 times. 5 times 6 is 30 equals, well, still got to do this. That's like a 1, right? I'm timesing by 10. Well, what's 10 times 9? 90. So don't forget to do the third term also. So now, once I'm here, whoops, sorry about that. I'm going to subtract 30 from both sides. Boom, die, and I get 4x equals 60. And when I divide each side by 4, I'm going to get an x equals 15. Okay? 2 more to do. Let's go to number 13. Okay, a point and a number, a point and a number, a point and a number, a point and a number. I'm going to multiply everybody by 10, which means I just move the decimal over one spot. Okay, once I do that, I have letters on one side, numbers on the other. Let's go ahead and get all my letters over here. Boom, die, and I'm going to get 14x minus 42 equals 28. Now I have to move my 42 over here. That'll give me my letters on one side and my numbers on the other. Now I divide each side by 14. Now I got to figure this guy out. Will 14 go equally in the 70? You know what? I think it is, and I think the answer is 5. But why don't we do this? Just to make sure, how many times will 7 go in the 70? Well, 7 will go in the 70 10 times, and 7 will go in the 14 twice, and you can see that that gives you a 5. So there's a way without using a calculator that you can go ahead and just recognize a way to reduce until you get a couple numbers that you can do in your head. Okay? So let's go over to 14. I see an 8, a 4, a 4, and a 4. Well, I know that all those numbers will go into an 8. Okay? So 1, 1, that's just going to be an X. A 1 and a 2. Can we all recognize that with these 4s, they're all going to be 1s on the bottom, and they're all going to be times 2? So that's going to be a plus 14 equals a 2x minus a 2. And we just solve from there. I'm going to move my x's over here, which is going to leave me with a 14 equals x minus 2. And then I'm just going to add 2 to both sides, which leaves me with an x equals 16. Okay, so again, those are a little bit nastier, but I think it's better than some of the the old ways that of having to use fractions where you have to find the common denominators and rewrite the first one. Just find that least common multiple times the entire problem by it. And it's going to really help you out. Or just move the decimals over the same number of spots, and you can be able to do these as well. And then they look like problems that you're used to. I hope this all helped you out. Good luck, and we'll see you in the next section.